So this is the molecular detection and putative vectors. We could not able to detect in any of this. You can see here with these protocols, we are not able to detect. Though in one of the insect like Neisseria nervosa, we could able to find identification. We thought that it was on coconut, so we may get. But when we sequenced, it was a endosymbiont, so there was no this one. However, we are able to get in the other which one involved already known vectors. And the seed transmission. So we try to go for there is a report that there is a seed transmission of this lethal yellowing Phytoplasma as reported about 18% through embryos. This is one of the major concern now, how to seed transmission to be prevented. So this is every time now it is becoming a news, only though it is reported that 15 to 18% of transmission and detected in vitro coconut plantlets in embryo. Opoja has reported recently. There was a meeting, also group meeting of Phytoplasma international workers we attended. He was also saying that he could able to detect in vitro cultured coconut plantlets from embryo. So these are that is the major international challenge for this one. And then we have checked the weeds also, the weed flora, whether any weeds harboring in the coconut plantations, the coconut Phytoplasma. So coconut root wilt Phytoplasma is reported 11th group. However, most of those 12, 13 weeds which were showing this type of symptoms, dicots as well as monocots, we can see they belong to different groups, not to the coconut Phytoplasma reported on coconut root wilt Phytoplasma. So there may be chances how it plays a role. We may have to find out what are the roles of these weeds in transmission or harboring the Phytoplasma. Coming to the diagnosis, as we all know, it is a long way, especially for us to in the plants like coconut. Though it was reported in 1970 itself for the first time when electron microscopy about the Phytoplasma in the root wilt disease, as well as serodiagnostics has been developed, and a lot of after 90s when the nucleic acid based diagnostics started, and real-time LAMP PCR, digital PCR also has come now. But whatever the detection methods as already available for this one has been tested. So real-time PCR is available, already published for lethal yellowing, coconut yellow decline, Veligama of coconut leaf wilt disease in Sri Lanka, root wilt disease in India also has been reported, as well as the LAMP protocols have been reported for root wilt as well as Veligama wilt. Digital PCR has been reported for group of Phytoplasma recently. So whether problem still exists at the field level, we can promising techniques confined to the lab, most of this, and needs more research for development of on-farm diagnostics. As we all know, simple DNA extraction techniques required, stabilized reagents, portable devices, user-friendly, especially for the crops like for plant palms like coconut and arecanut. For us to go for even the sampling, we need to climb the tree and get the meristem type of tissue, means it will be very difficult, but it is very difficult to get from the others, DNA, isolating the DNA from the other older leaves or even from the stem or peel, this one. Uneven distribution of Phytoplasma is another major issue, and low concentration of Phytoplasma. So nested PCR at RT-PCR and LAMP assay, no consistency, whatever, though we have reported that it could able to detect, but we are not getting the consistency and need to be improved, and we need to make a reliable and field level diagnostics for this. So regarding the management, it is as we all know, Dr. Rao also highlighted what are the different methods. So here we are, our aim was to go for sustainable yield, though we know that it not be cured once infected. So the farms cannot be removed when there is a severe incidence also. So there are the approach which was followed was in newly emerging areas. It is the surveillance. Surveillance is the one which makes the this one, and eradication, buffer zone creation and containment. This was the strategy adopted. Whereas in case of endemic areas, it is integrated management to sustain the yields. Live with the disease as the major strategy, and thrust on enhanced income per unit area to go with different types of crops or different nutrition and microbes application, all those things. Prime strategy, emerging the Phytoplasma disease in new area, surveillance and eradication, confine the disease in a limited area and create a buffer zone. This is what has been followed for in Kerala. Root wilt, the severe, though it has been now observed in Tamil Nadu, parts of as well as Kerala, a little bit parts in sporadic incidents, whereas the major endemic has been confined only to southern 8 districts of Kerala. Has been still, this is one of the surveillance in eradication timely as well as through that. So it is one of the major aspect is to go for regular surveillance and monitoring is the, as of now, that is the first method. Then breeding for resistance. In case of root wilt, we do have developed some this one in world over also. Jamaica and this green dwarfs are to be shown to be resistant to this one. In Jamaica, into Panadol. So lethal yellowing was reported, but it is breakdown has been observed. In Sri Lanka and Nigeria, green dwarfs have been reported to be resistant. India, we have come up with Indian Kalpashri, Chaugat green dwarf, Kalpa Shankraksha, Malayan green dwarf, as well as Kalpa Shankara as a for cultivation in root wilt endemic areas. It has been now multiplying under our curriculum center. Coconut Phytoplasma dwarfs, especially green dwarf cultivars from Asian countries, promising source for resistance, needs more studies to broaden the genetic base for this. That is the this one. So integrated management of the sustainable income. This is the one which was followed through even our institute. It was given more emphasis and how to get the income even for whether for it is for root wilt or for the YLD. So this was the as present they have recommended, as well as the demonstration has been shown that intercropping or mixed application of this one. So farmer participatory approach was found to be very successful, especially in the endemic areas like our southern Kerala. Some of the districts were taken up and it could able to increase the yield. So Black's approach has been followed in the same type of farm quarantine in case of Jamaica. This is the approach which they are following in Jamaica for increasing the yield in the affected trunks. So concluding, I will just tell that there are a lot of nowadays reported recent years, lot of phytoplasmal identification, even the palms also, many phytoplasmal groups have been reported. However, one of the issues is still we have a field level diagnostics kits at the farm level. We are not able to identify accurate identification of the many of these protocols, especially for us, coconut and YLD of arecanut. We are not having a suitable, a very reliable and repeatable protocols. Though we could able to detect, there is no consistency. We are not getting. That is the problem. Epidemiological factors. There is the gray area, as we told. Phytoplasmal vectors remain unresolved in majority of the farm diseases. Not only here, in though others, some work has been done. Still, it is a major internationally. Majority of the breeding programs on resistance to coconut phytoplasmal disease focus on green dwarfs alone. So we may have to broaden the space because mainly green dwarfs were found to one, and most of their focusing only on green. Of advanced biotechnological tools may help in accelerating the disease resistance breeding programs. This has to be checked up whether we can use some other, as we told, it has to be a molecular biologist to biotechnologist or other disciplines have to integrate and take up this work. Unless we do that, we will not able to get the good resistant variety or for these things. Needs validated location specific sustainable. Till we get this one, we need a specific sustainable palm-based cropping system models to de-risk the farmers. We have to give a proper system. That's what we are working out, multi-species, where the location specific, where we can grow which species of the plants has been worked out to a certain extent with our institute, and they have been popularizing the cropping system models at different places where the this root wilt problem is there. Future thrust is to establishment and strengthening the network of domestic quarantine station with the diagnostic labs. Palm disease diagnostic network is a must, as we are. I think this is the platform which will help us to have a network, and we may have to find out how best we can utilize and get the money to make it a very good proposal for this, having a network fund to develop a standard protocols and procedures for production of disease-free planting material. We need the standard protocols to be developed. Develop user-friendly diagnostic kits. That is another major issue for us, though we are working on it. We are not able to get the reliable detection methods, consistent detection methods we are not getting. So we are working on that. Strengthening the resistance breeding strategies is another aspect which we are telling. Decentralization of disease-free planting material production is the required wherever, especially this root wilt has been reported. Now this has to be meant, and molecular detection and characterization of the this Achenorhynchus fauna and weeds are the essential, as well as metagenomic and transcriptomics of healthy and root wilt affected palms to identify the microbial communities involved in disease suppression. These are some of the future thrust. We have initiated some of the work, but still not having that result. So we'll be able to come up with, especially metagenomics and transcriptomics work we have initiated, and vector characterization also has been initiated with our institute. So with this, in brief, I have given the global scenario about this one, and most of the things have been published. I think I thank organizers for giving this opportunity. If any discussion is there, we can take.